Hey folks, how's it going? Dr. Emily here, and today I'm talking about what it takes to build great software in 2025. And in fact, today what I'm going to be talking about is we're going to be taking insights from an oldie but a goodie. This is the Mythical Man Month Chapter 1 called The Tar Pit. This is a book by Fred Brooks. It came out 1975 and it was so good. It was an instant classic and it was so good. It's now out again. It's now out again. So it's been re-released in like 20 years later. This is the 20th anniversary edition. And the reason why is because the concepts that they figured out, the principles, are timeless. And yes, even in the age of AI, they are still absolutely essential. So let me share with you, right? And we'll go from there. All right. So let's figure out why in the world is software development considered being like a tar pit. Okay, why is it a tar pit? So if you think about a tar pit for a second, right? Okay, a tar pit, you're going to get stuck in a tar pit. And if you're joining us live, drop a hello so I know that you're here. Or if you're watching the replay, love to know that you're here and answer your questions. Modern software development is a lot like a tar pit. What happens when you walk into a tar pit? Are you able to get out? Not necessarily, right? Sometimes we get stuck in the tar pit. We get stuck in the tar pit. And the worst part about the tar pit is you might get eaten. Yes, you might, in fact, get eaten in the tar pit while you're trying to get out. You're stuck, right? So an elephant, a woolly mammoth, they walk into, I don't know if woolly mammoths walked into tar pits, but here we have some big beasts in the tar pit. They're stuck. They're trying to get out. It's like quicksand, right? They're just like stuck in this quagmire. And then there's these jaguars or cheetahs or lions hunting after them. So while you're stuck in the tar pit, you can't get out. And this is a lot like building software. Yes, even in the age of AI, these principles haven't changed. And that's how you know a principle is truly foundational, when it doesn't change. For instance, we have this concept in physics too. Sometimes our understanding of physics changes. And so right now, gravity, we're pretty strong. We're pretty rock solid on gravity, right? That it works on Earth. That when I throw something up, it comes back down. Okay, awesome. So that becomes an essential principle, right? It's tried and true. It holds up. We observe it many, many times. So how can I say that a book that came out in 1975 about software development has relevance today? Because it still has essential truths, because software is a human endeavor. Humans collaboratively bring forth and create something that never existed before. So there are some fundamental underlying truths behind that process. And the faster you learn to work with those challenges and principles, the more effective you'll be as a developer, as a technologist. So, okay, why is Brooks saying that modern software development is like a freaking tar pit where you're stuck in a quagmire and you're going to get eaten? Because that's essentially what happens, right? The team is working and they peel back a layer and they think, oh, this will take me 2 weeks to build. I got AI in my back pocket, right? Let me just, whip this out. I'll get this. I got this. It's all good. Okay, excellent. And then you get into it. And then you peel back the layers. Like, oh, I have to learn about this thing. And then that connects to that thing. I need to learn about that thing and that thing and that thing and that thing. And in fact, right, Eric had mentioned that, Udemy Hell tutorial Hell trying to learn how to become a software developer, right? It feels like a tar pit you can't get out of. The same challenges exist for every software developer. We're constantly deciding, is this learning investment worth my time, right? This is what we have to essentially figure out, because there's always more to learn and there's always more problems and challenges to be faced. So this idea that building software is kind of like a tar pit is a really good one, because when you first, like, let's say you've got your first job as a software developer, you're walking in, you have no idea what you're walking into. It could be the most amazing software development team on the planet. They could be horrible to deal with. It could be the most incredible clean source code you've ever worked on. It could be a tangled mess of spaghetti code. You don't know. You just walk into this position and you have no idea what you're going to get. You find out the best you can on interviews, right? You do the best you can. Okay, so we've walked into this software project. We don't know the lay of the land. It's a little bit like the tar pit. We're stuck. we're employed now and we have to deal with it for better or worse. Okay. So we walk into the system and we're expected to figure it out. The whole organization is functioning and they know how to do things, but you're the new guy and you have to figure it out. And so from that point forward, you're learning to navigate from within. It's a working project. It is in motion. It is in stream, and you have to just hop on in and figure it out. It's kind of like learning to surf, right? You're going along, you hop on the board and you're just going with it. Well, you don't quite know where it's going. You don't know what's going to happen next, but you're building the software and you're delivering, right? This is what you're doing. So this is the challenge of modern software development. This is the challenge. So just to kind of put this into perspective, the 2025 software landscape, complexity hasn't disappeared, right? It's actually exploded because not only do we have all the challenges that we had before AI came out, now we have AI added into the mix. There could be AI pipelines and machine learning pipelines. There could be distributed systems, right? Like the tech could be all over the place. It's not just on our computer. There's servers all over the place that can go down, that can get upgrades, right? There's things that you don't have control over. And whenever you don't control the process, you have to allow that little bit of extra wiggle room to make it work. So there's microservices, there's cloud platforms. It's crazy. It's exploded. It's awesome. There's just so much opportunity, but keeping a handle on it and not allowing it to completely overwhelm you becomes the challenge. And so Brooks is calling this the tar pit, that software is so powerful and useful, but it's unforgiving and it keeps going. And the client's either happy or they're not. And there's some extra challenges there. So let me walk you through what those look like. So one of the challenges we face as programmers is we're perpetual optimists typically. And that's in part because you couldn't become a software developer without some amount of optimism, because you have to believe in the ability of technology to solve your problem and your ability to execute it, even if you've never seen it before, because by its very definition, software as a medium of creation is something that has never been created before. It's never existed ever on the face of the earth. So you have to be a little bit optimistic to even be bold enough to dream and envision that what you or your client thinks is possible could actually exist, right? Could actually exist. So super, super important. Yeah, we have some great comments here. So Eric's commenting, sometimes think AI has dumbed down some of the competition, making it easier to shine if you work harder than those using AI. Yes, right. It is really important to actually understand how to solve problems. It is so smart, Eric, so smart. And our Udemy is great, but you learn more from figuring it out on your own. Absolutely. There is a place for knowing how to do it yourself in the land of AI, because how do you know if the AI is lying to you? It becomes a problem. You have to actually know what you're looking for. You have to be able to recognize that AI has successfully given you what you wanted. And so you need some level of knowing how to do it yourself, and at least implementing it to test it out yourself, right? Before you know if AI has really done what you've asked. So with this perpetual optimism, right? Software as a creative medium is completely unconstrained. It's not like sculpture or construction where you're bound by the physical limitations of what you've been given. In software, if we're bound by a limitation, we overcome it, man. We just reinvent the wheel and we go, right? So programmers have to be perpetual optimists. But the flip side is that programmers tend to underestimate how long something will take. I don't think this is unique to programmers. I underestimate how long things take me in all areas of my life, not just programming. But in general, it's really hard for software because by definition, we're creating something that's never existed before. Now, if you are trying to build something that has been built before, you can be a little bit tighter on your schedule and your timelines because it's been done. It's a known quantity. But usually we're building software because it's brand new, right? Unless you're taking an old language like COBOL and you're porting it into a new language, right? Like you're creating something new when you're creating software. So smart planners and managers build that into the schedule. In fact, inside TechJoy software, when we're serving our software clients, we will take our actual estimates and quadruple them. And we'll try to get them done in a week, see how far we get, see what results bubble up. And now we've got a couple more weeks before we're actually demoing that. right? So we actually build that into our schedules, and our approach is a little bit unique because we're working with learners. But smart planners and managers that work on software teams build in this uncertainty into the schedule if they want to be successful. So the result, though, is that for the most part, software is almost always late, over budget, or missing key features. And in the industry, the rule of thumb is pick 2 out of 3, right? So we deliver super high quality work that has key features, and that we deliver it either on time or on budget, right? Typically it's both. And it's rare. We almost never go over budget. We will extend the time if needed, but we won't go over budget. And so that's really unheard of in the industry, that we offer that kind of guarantee. But the rule of thumb is you get 2 out of 3. You don't get all of them. You can either pick high quality, right? You can pick on time, or you can pick on budget. Because at the end of the day, every software project is almost like a research project, right? Like, you don't actually know the answer. Like, no one knows the answer. No one's ever built it. It's never existed before. And so, like, this is a really challenging thing to learn how to do. Now, yes, this is true even in the age of AI, because it still has to work, folks. And it has to actually meet human needs. A human has to sign off on it and says, yes, that meets my needs. It has to go live into a human system, and they're going to give you feedback and want improvements. And so the things that make software hard, they're still there. They haven't changed or gone away with AI. To be honest, AI took one of the simpler areas of software development, the coding part that doesn't have any human interaction whatsoever, and made it faster. But all the pieces that tie to humans are still there. It's still there, folks. So at the end of the day, yes, AI has accelerated our timelines, but it's only given us additional emphasis on the hardest parts of software to get right, which is actually meeting human requirements and creating software that actually meets people's needs. That part hasn't changed. So AI has revolutionized prototypes, right? You can bang out a prototype super fast now. But the hard part's not getting the prototype, although that used to be one of the most expensive barriers to entry, right? So now we should really see some fun stuff coming out. Now that's not a barrier anymore. But at the end of the day, it's about creating a sustainable business, working on a team, working to actually over deliver on what the client wants and adding value. Like, those things haven't changed. And so what's happening is there's a real need and niche for people that speak both human and software, human and tech, because the tech part, it's harder and harder to just exist in this tech silo where all you do is code anymore, right? The best software developers now who are doing the best work are doing it closer to the human, closer to the stakeholders, closer to the clients. And AI hasn't changed that, right? It's actually just pushed people closer, right, into that ecosystem. So super, super exciting. And yes, so Dan agrees. 3 to 4x is something you've done for a long time. Is best practice to keep a manager off your back. Exactly, right? So making sure that you absolutely bake in extra time. And if you're a solo developer working on your own, allow twice, like 2x time. But to be honest, in my organization, we allow 3 to 4x, right? We assign an aggressive deadline that we think is doable, and then we allow 3 to 4x, because even if it succeeds in that first week, that first time frame, now someone has to test it. We need automated test infrastructure in there so that if anyone else makes changes in the future, it doesn't break, right? So there's a lot of elements that go into creating robust, scalable software. And yes, AI can help accelerate all of it, but somebody has to sit there and be the hands and actually set it up, right? I mean, someone has to test it. So there's still technical elements. And yes, AI will get better and better, but at the end of the day, like, knowing if it actually worked, only the human can do that part, right? Like, the human has to be like, yes, this is what I wanted. And it has to like go share it with other humans. Otherwise you don't have a business, right? You don't have a software business. So these are all super, super important. So even though software can be challenging, it is joyful because we're making things, and that's super cool. And we're creating things that are useful for others. So it's an amazingly rewarding endeavor. And it has the intellectual brain teaser puzzles of problem solving. It's so much fun, right? When it can be challenging, right? Don't get me wrong. Being a programmer, it's definitely a labor of love, right? Because you're growing, you're learning, and you're building. And so you're creating these awesome things. And sometimes you get stuck. Every time we get stuck, it's a call to us to learn to grow more. But that challenge, right? You're constantly learning. No two challenges are exactly the same, because if you had the same challenge, you solve it because you already solved it before. It's super, super cool. It's such a fun way to be. And so there's just this thrill of the continuous learning. But some of the challenges of software, right, is there's this demand for perfection. And I do see that there's a lot of perfectionism in programming, because programming, for the most part, as a discipline, is about, okay, what's the best that we can do? We're shooting for perfection. We often don't always achieve it, but we're working towards it. And because there's a lot less of a human element to it, it's actually a more controlled environment. But there is this dependence on others and a lot of incomplete information. And when you have a real system, like that scenario I talked about earlier, right, just earlier in this session today, is, you walk into a large system and you have to fix a bug and you don't even know where to begin, right? Oh my goodness. Because that's really the first task that a lot of companies will ask for, is they're going to put you through your paces. They're going to give you something real to do. They're going to ask you to do something with it, with your knowledge, and show that you can show up and be successful no matter what, right? All these same things. And there's a lot of projects that fail or show up too late. Or I've even been on projects where we 100% delivered exactly what the client was looking for, on time, on budget. They still didn't use it because a higher decision maker above the project decided it wasn't worth it. So no matter how good your work is, at the end of the day, whether or not it gets adopted is a totally different situation. Whether you're a tech founder, right, looking to build your own SaaS product, or if you're working on a team, right, you could be working on an internal team and ultimately that project momentum gets scrapped and you get reassigned, or worse, laid off, which has sometimes happened in tech as well. But if you know what you're doing and you actually know how to solve problems, if you show up and you do the work, you're going to get there, right? And you're going to get hired and you're going to have an awesome, awesome resume. So what are some of these modern strategies to build great software, right? So things, if you're a software developer looking for a six-figure role, some things you want to focus on: modular architecture and microservices, right, that allow us to isolate the complexity, right? We want to decouple as much as we can so things can vary independently, and we're just focusing on those connections, on the APIs and the information that connects them. Using higher level languages that make life easy and making it serverless, right? So we can cut down on the burden of how difficult these things are. Now, something that we use all the time, and it's absolutely essential for the projects that we deliver, is continuous integration and test automation. These allow us to have faster feedback loops. And yes, with AI too. And you can ask AI to build these things if you know, right, to ask for them. And then what this does is, as your project evolves over time, as soon as you introduce new code, you run it against the old tests and make sure you didn't break something that was already working, right? It's like that idea that if you, like, have you ever seen that picture of like a bunch of pipes leaking with little holes, and someone goes to plug one hole and then another one shoots up, and you plug another hole and then another one shoots up, but you don't have any more hands. So you take it off this one, you plug it over here, and that one goes back up again, right? That's that kind of whack-a-mole style of plugging holes is something that we do in software all the time when we have to fix bugs after a project is live. And this is where I think people really miss the boat in the age of AI, is that, yeah, sure, you can develop a prototype lightning fast, but guess what? It has to actually live and do stuff and have real users working with it. And guess what? They're going to break things. They're going to ask for new things. And then who's going to be there to like do the patchwork, right? Like AI systems, like they don't just fix themselves. Although we've been working on it for a long time, like decades. In fact, we've been working on code that heals itself. It's a non-trivial challenge. So what we really want to focus on is getting the MVP up as quickly as possible. Totally on board with that. But as soon as you have your MVP functional, you want to take that time to build out the continuous integration and test automation pipeline. Many people say you should build this out from day one, but as someone who coaches tech founders who are looking to build their first software product, I don't recommend that, because speed to market is key and you need that user feedback as soon as possible. So the way we work with that in our organization is we deliver the MVP as quick as we can using AI as much as we can. And then once we can hand that over to the client, they're going to go out and start building their audience, building their network, building their users, their beta testers, getting feedback, getting ideas for how they're going to like change this product to make it even better so they can actually get paying clients, right? Paying customers. And so then while they're doing that, as a team, the tech side, we're building out the continuous integration pipeline, right? We're building out the test automations so that any changes the client asks for from here on out are being tested against the existing version. Super, super awesome. Yep. No, such good rewards, such good rewards. Yes. And there's so many rewards in that feedback loop. Absolutely, Dan. So, so good. So, so good. But what I'm specifically referring to about feedback loop here is an automated one that's testing your functionality to make sure you actually built what you wanted. And so the way we do that is typically called test-driven software development, where you build the test before the code that implements what the test is testing. So it's like, let's say I wanted to create a function that adds two numbers. I would write the test, does 2 + 2 = 4 first. This is actually good best practice for software development, but it's also super awesome for helping make sure you understand what needs to go into your function, because you've already stated, here's the input, the parameters, here's the output. This is the result that my function should have. And then you go build it. It's actually the way we understand the problem too. So it's a win-win, right? You're getting that automation, but you're also, making sure you firmly understand what it is you're building. So super, super awesome. I love it. Yes, absolutely, Suzanne. Yes, TDD is pretty awesome. It has its use though. I would say that in a MVP style environment where you're trying to launch a new tech product, I actually don't necessarily advise TDD because speed to market is just so valuable, and speed to user feedback, right? Are you building the right thing? How little money can you spend to answer that question, right? That is the name of the game, at least from the business perspective, on the business side of things. Okay. So we also want to have, clear domain models, aligning the code with the business intent. This is fancy words for making sure you understand what the client wants, right? And then delivering it. And that's where these faster feedback loops come in, right? I was specifically talking about automated feedback loops, but you're right, Dan. Dan had mentioned this before, is we're really looking for, that faster feedback loop with the humans too, right? It used to be you'd say, okay, design me a system, go spend 6 to 12 months and give it back. That's not the way software is built anymore. It is for mission critical and safety critical applications like a rocket launch, moon launch, cancer treatments, like medical treatments with lasers, things that could kill people or cost millions to billions of dollars. Yeah, you might still want that really long software development life cycle. But what we're looking for in the startup world is how fast to client feedback, how not every idea we have will be gold. How fast, how little time can we spend, how little money can we spend to get that answer? That's the name of the game. And in fact, what I do with my business clients, our software clients, is actually we work with them on making sure that even the idea of the software is viable before we even build it, is what we try to do. So super awesome. It depends, right? If someone comes in, they're like, I want to build this, right? I'm not going to stand there and be like, no, you have to go through all this business validation first. If you want the software, we'll build it for you. But for students that come to me, for clients that come to me and they're a little bit uncertain about what they want built, we test it, we build it, right? We make sure we're testing the idea and the marketing and all those pieces before we even build it out. So we can make sure that we're building software that's going to walk into a warm audience that's actually ready for it. Pretty cool. Awesome. Super awesome. So just to, kind of pull this all together, right? So Brooks outlines how important people and communication are. This is partly why it's a tar pit, right? And so our best practices in 2025 is to have small cross-functional teams. It's actually a 2 pizza rule. If you can feed the team with 2 pizzas, it's the right size. If you go beyond that, it's too much. Google did a study on this. The recommended size is actually 4. Internally, because we work with part-time students that are still learning, we actually typically start with a much larger team, and we kind of see who pans out and who's a good fit. And using Agile for clarity, and just really working to share that code. So bringing it all together, we want to respect the tar pit, embrace the complexity of the software development process, but work to simplify it as much as possible by mitigating accidental complexity as much as we can. So we don't want to make things overly complex if they don't need to be, right? Simple scales. And we're building for that scalability, that clarity, and for fast feedback, fast iterations, and having empowered team communication and ownership. I would say that 99% of the time, the challenges I see in a software project are communication based. It actually has nothing to do with the tech challenges. Tech challenges are fun, right? That's the fun part. That's what we're here for. But typically what holds a project back is the communication, right? Whether it's between the client and the team or within the team itself. That's usually the bottleneck. Once you nail the communication structures down, it's usually smooth sailing. And that can persist as long as you have a critical mass of people and team members that like get the lay of the land, that get how the organization functions, and they move forward together. It's pretty cool. And just to celebrate the joy of building things and problem solving and having an impact of creating things that actually matter. So cool. So cool. So just to summarize, right? So Brooke highlights in his first chapter of the Mythical Man Month, the demand for perfection, right? And how it challenges software developers to this day. But the solution is iterative development practices with a continuous integration, automated testing. It's called CI/CD, continuous integration, continuous deployment pipelines. And it really helps mitigate that. Another challenge is dependency and coordination, right, of people on the team. And so the smaller you make the teams, but make sure that they have the makeup of all the people with the knowledge is really, really important. Helping people work asynchronously and with full transparency, because at the end of the day, software development is brain heavy work, and interruptions mean you can't get your work done because you have to get into the state of flow. And once you're like in the zone, it's a thing, right? Like you're in the zone. You don't want to be distracted by communication. So you have to set things up to be async. When systems are complex, the likelihood of bugs goes up, and it's really, really challenging, right? Like that's part of the tar pit for sure, is that like you have no idea something's not working and you have no idea where. So smart programmers actually build systems, right? Like automated testing and it like inserting little things in their code to actually make this easier, right? So if we change how we develop, it can actually make bug hunting almost like a thing of the past, like super, super easy. And finally, things being obsolete and having delivery delays, making tighter feedback loops, both in terms of testing and with the clients, delivering fast MVPs, continuous deployment, like always delivering for our clients. Once we have the MVP delivered, we're just continuously delivering, right? Every single week, we're delivering new tweaks, new updates, and it just goes from there. It just goes from there. Super, super awesome. Super, super awesome. And yes, Dan, absolutely. Getting ideas out of people's heads and into sufficient detail is absolutely a huge challenge with software, which hasn't gone away with AI. Although perhaps it can be facilitated and accelerated, it's still here. All right. Now, I want to let you guys know something. So this Thursday, I'm going live on the AI Developer Blueprint, how smart coders are using AI to build six-figure tech careers and how you can do it too. So it's a live masterclass this Thursday at 9 p.m. Eastern. If you want to sign up, please join us at joc.mobi. Here, I'll type it here. All right, make sure it works there. Hopefully that link will work. I'd love to see you there. So let me see if I can make that actually show up as a link. I'll give that a shot. We'll see. We're live. joc.mobi. Maybe put some slashes in there. See if I can do that. There we go. All right. Hopefully that becomes a clickable link for you guys. I'd love to see some of you there. Awesome sauce. So this is going to be designed for beginners and more advanced students alike. It's really designed for people that are just getting started, right, on their journey to becoming six-figure software developers. Academy students, you've probably seen it before, but you're welcome to join us. If there's any questions, please don't hesitate to drop in the chat. It's been absolutely amazing speaking with you today. And if you have any questions about building software or how to become a six-figure software developer, I hope you'll connect with us and reach out. We'd love to help support you. All right. Have a great rest of your day, folks. Happy coding.